Good evening, everyone. In the last videos, we discussed very clearly about what are the different ways are there to represent these graphs. We have two ways are there. One is adjacency matrix. Second one is nothing but adjacency list. Sir, both we covered very clearly in our last session. Now, in today's session, we need to talk about, okay, in today's session, we need to discuss about, okay, so something like a traversal. What is mean by traversal? How we can able to work with this traversal? All these things we are going to discuss in our today's session. Let us start now. Right. So there are two types of traversals are there, sir. One is nothing but BFS, another one is nothing but DFS. Anyway, we are going to discuss in detail about this one by one. I think yesterday we have taken one example also to demonstrate that BFS and then DFS. Let us continue from that. Yeah. Sir, have you observed, if you take this graph, first we are going to see how we are going to write BFS. What is the first step? What is the first step that we have to take here is, sir, we need to visit. Okay, we have to visit each and every node only one time. You have to visit each and every node one time. Sir, first I visited 0. I visited 0. Sir, I have inserted this 0 inside this queue. Okay, since it is BFS, breadth first search. DFS means depth first search. So it is something like level order traversal, what we discussed in our previous sessions. Sir, we have to put the first vertex in our queue. So 0 is inserted into the queue. Let me rewrite from the beginning. So we have to maintain a queue. My source vertex is 0. First, we have to take that 0 inside queue. Then, so what we have to do here is, after putting this source into this, then we have to check, is my queue is empty? No, queue is not empty. Then what we have to do? So remove this element and put it in BFS. 0 got inserted. Next, immediately, what we have to do here is, sir, you need to check the adjacent list for this 0. For 0, which nodes are adjacent? Sir, I can say 1 is nothing but adjacent node, right? 1 is nothing but adjacent node. Okay. So because it is connected to 1. So what we have to do? We need to check whether 1 is visited or not. So 0 is visited. So 1 is not visited. False will be there. So all these elements are false. Okay, since 0 is visited, I updated this. Sir, is 1 is visited? No. Then what we have to do? If 1 is not visited, try to, okay, try to make it as a visited. Try to make it as a visited and try to put it into the queue. Now 1 is there in the queue. Sir, next, what will happen? Is there any adjacent node for this 0? No, only one adjacent is there. That's why completed. Next, we have to check, is my queue is empty? No, my queue is not empty. So delete the next element. Next element will be 1. So I'm going to take that 1 in this place. Okay. Sir, next what we have to do? Sir, which nodes are connected adjacent to this 1? Which nodes are connected 2 and 4, right? So we have to add that 2 and 4 into this queue. Okay. And make 2 is visited and then 4 is visited. Like this you have to make. Next, is my queue is empty? No. Then, so delete the node 2 and then insert into this BFS. Now check the nodes which are adjacent to 2. Sir, which are adjacent to 2 here? So we have 3 and then 1. But 1 is already visited, 3 is not visited. Make 3 as a visited and try to insert here. Okay. Sorry, 1 second. We have to insert that 3 in the queue. Sir, completed. Next, is there any other adjacent nodes to this 2? No, we don't have any. So next, what we have to do? Sir, 2 got inserted in this BFS. Next, is my queue is empty? No, my queue is not empty. Sir, we have 4 is there. Okay. Now what we have to do? Delete this element and try to push here and check adjacent nodes for this 4, sir. Which are adjacent nodes for this 4? 1 and then 2. Sir, 1 is already visited. Okay. 3 is already visited. So no need to put these two into the queue. Sir, fine. Is still my queue is empty? No. Sir, extract 3, delete 3. Try to put it in BFS and check adjacent nodes for 3. 2 and then 4. 2 is already visited, 4 is already visited. Is my queue is empty? Yes. This is nothing but BFS for this graph, sir. This is nothing but BFS for this graph. I will take one more example for you to better understand. Okay. Sir, what is the next example? Is so consider I have a node like this. So consider I have some 4 nodes are there like this. This is nothing but 0th node. This is nothing but a first node. So this is nothing but a third node. This is nothing but a second node. Sir, what about the links? 0 to 1, a link is there. Okay. And then 1 to 2 link is there. So 2 to 3 link is there. And 1 to 2 is also link is there. So I want to find out BFS for this. Okay, I want to find out BFS for this. Sir, how you can able to find BFS? Okay, first we have to maintain a queue. Start with vertex 0 and we have to maintain one visited array. Okay, how many nodes are there? Only 4 nodes are there. I think better you can draw with 4 elements. Okay, 0, 1, 2, 3. So 0, 1, 2, 3. Sir, 0th node. So try to put it that 0th node into the queue. Try to put that 0th node into the queue. That is the first step, right? So we have to add that 0 to the queue. And so print in the BFS. 0 is nothing but the output. Next, make that 0 as a visited. Next, we have to find out the adjacent nodes for 0. Sir, which are adjacent 1 and then 2? So let us add these two into this queue. Now check, is there any adjacent nodes? No. Then, sir, try to fetch the next item. 1. We have to make it as visited, right? Yeah, we have to make it as visited. True. And then true. Sir, remove 1. So we have to insert in this BFS. Next, sir, you have to find out the adjacent nodes for this one, 0 and 2. Sir, is 0 is visited? Yes. Is 2 is visited? Yes. So we are not required to add. Is my queue is empty? No. Try to get the next element, which is nothing but a 2. Try to append in this BFS. Sir, what are the adjacent nodes for this? 1 and then 3. 1 is already visited. No need to add. 3 is not visited. Make it as visited and add it into the queue. Is my queue is empty? No. Then, so remove one more element, 3. Try to put it into this BFS. Adjacent nodes for 3. We have only one adjacent node is which is nothing but a 2. But that queue is that 2 is visited. Okay. So we are not required to add. So my queue is empty, right? Yes, that's all. This is nothing but a BFS for this particular graph, sir. Like this, you have to go for BFS, breadth first search. First, we have to find out its adjacent nodes, and from that adjacent, which list is going to come, like that we have to trace. Okay. I think you people got very clear clarity about this BFS. If you are okay with this, I will take one more example and demonstrate for you people. Can you please confirm, is this concept is clear for you people, friends? Is the concept is clear for you people, friends? Please confirm. Yes, I request everyone to please respond. No response from your side. I have not written any code, just at the top level I am explaining. We have to take a node. You need to find out the adjacent nodes for that node and we have to add that particular things into the queue. One by one, we have to remove from the queue and we have to, yeah. Multiple examples I will cover. Up to this clear or not? That's what I am asking. Simple examples. These are clear or not? Right. Sir, one more example I am taking. Listen carefully. Sir, in this example, sir, I want to take a big tree like this. Okay, I want to take a big tree like this. A big graph I am going to take like this. Sir, what about the connections in the sense like this? We have some connections. Okay, so this node is nothing but 0. So this node is nothing but 1. This node is nothing but 2. This node is nothing but 3. This node is nothing but 4. This node is nothing but 5. And this one is nothing but 6. This one is nothing but 7. See, please observe my process, sir. I am going to traverse BFS. So if you want to work with BFS traversal I want, we need to maintain a queue. In addition to that, we have to maintain one visited, because in this graph, you may have a cycles. Okay, you may have a cycles. So 0 adjacent node is 1. 1 adjacent node is 4. 4 adjacent node is 7. 7 adjacent node is 5. 5 adjacent node is 2. 2 adjacent node is 0. Already we visited 0, right? That's why to make that confirmation, we are maintaining one Boolean array called visited. In this Boolean visited array, what we are going to do? We will maintain statistical report. Okay, we are going to maintain statistical report of these visited graphs. By default, every vertex is not visited. So by default, the values in this array will be always false. Okay, like this we have. Sir, first we have to start with the source vertex. Always my source vertex is 0 in these examples. Sir, is this 0 is visited? No, right? Then what we have to do? First we have to add that into the queue. 0 is added to the queue. Sir, is this node is visited? No. Make this node as a visited and remove these, and we have to print it in BFS. Okay. Sir, after this, you have to find out the adjacent nodes for 0. Which nodes are adjacent for this 0? Which vertices are there? So 1, 2, and then 3. Sir, try to add this 1, 2, and then 3 into queue. At the same time, make that nodes as visited. This is the first step. Next, sir, completed, right? All nodes got adjacent nodes we got. Next, remove the next element from the queue, which is nothing but 1. Try to put it in BFS. Now find out the adjacent nodes for 1. Which are adjacent for 1? 0 and then 4. But 0 is already visited, right? So no need to add into the queue. 4 is visited? No. Try to make it as visited and try to put it into the queue. Sir, next. Sir, is my queue is empty? No. Sir, remove the next element, which is nothing but a 2. Try to print on the BFS screen. Then you have to find out adjacent nodes for 2, which is nothing but 0 and 5. 0 is already visited, but 5 is not visited. Make it as visited and try to pop. Okay. Sir, next what we have to do is my queue is empty? No. Try to get the next element 3. Try to print and find out adjacent nodes for 3. 0 and 6. 0 already visited. 6 is not visited. Make it as a true and then try to put it into the queue. Is my queue is empty? No. Take 4. Sir, we have to print 4. Try to identify the adjacent nodes for 4. Sir, what are the adjacent nodes for 4? 1 and then 7. 1 is already visited, but 7 is not visited. Try to add into the queue and make them as visited. Sir, is my queue is empty? No. Try to pop the next element, 5. Is 5 is visited? Yes, already it is visited. So I am not going to print that. So sorry, we are not going to find out, I mean adjacents, because 2 and 7 already visited. Just we are going to print. Next, remove 6. Print and check adjacent nodes for 6, 3 and then 7. These two are already visited, so no need to. Next, remove 7 and push it into the BFS. Now, sir, is there any adjacent nodes for 7? Yes, 4, 5, 6. But 4, 5, 6 are already visited. That's all. Is my queue is empty? Yes, this is nothing but breadth first search traversal for this graph, sir. Can you please confirm? Is the concept is clear at least now? Everyone, just I'm explaining the theoretical processes, sir. Beyond that, nothing. So once if you see the practical code, you people will get clarity. Now, sir, I will write a program for this. Okay, I will write a program for this. Let us see how it will be. What is the use of it? Ayo, sir, we have so many uses are there. Maybe tomorrow, day after tomorrow class, you will get clarity. Okay, I don't want to discuss now because you people are going to get confused. Now, sir, listen carefully. Listen carefully. Graph, graph I am taking. Sir, which example I am going to take at the very beginning? Please listen, sir. I will take this as a first example. Okay, this as the first example. How many vertices we have? 5, right? 1, 2, 3, 4, 5. So I am creating a graph with 5 vertices. Okay, and we have to add a undirected edge. Undirected edge. Sir, which one is edges here? 0 is connected to 1. Okay, I am going to take 0 is connected to 1. Next, I want to do this same process for remaining nodes. Sir, what are the remaining nodes here? 0. Any other adjacent thing is there? No. For 1 which are adjacent, 1 0 is there. Anyway, we have added 0 1, right? No need to add 1 0. Next, we can have, sir, 1 2 is there, 1 2 is there, and then 1 4 is there. Two nodes are connected. Next, for 2, already 1. Sir, already we have taken 1 2. We are not required to add 2 1. And 2 3 we can take. 2 3. Sir, any other nodes from 3? From 3, sir, for 3, 2 and 4 are adjacent. So 3 to 2, already 2 to 3 is there. We are not required to add. 3 to 4 we have to add. 3 to 4 is there. Okay, next, and after that 4 to 1 is there. Okay, 4 to 1 is there. We have to take that 4 to 1. Next term we can take 4 to 3, but already 3 to 4 is there, right? That's why we are not required to. But let me check up to this, is it really correct or not? We have to cross check. Okay, 4 to 1 is also there. Yeah, 4 to 1 is also there. I think no need to add because it is undirected graph, right? It will be added automatically. Now check, really is it giving correct answer? Sir, 0 is connected to only 1. Yes, sir. Now next output, 1 is connected to 0 to 4. 1 is connected to 0 to 4. Perfect. Then 2 is connected to 1 and 3. 2 is connected to 1 and 3. Excellent. 3 is connected to 2 and then 4. Sir, 3 is connected to 2 and 4. Excellent. 4 is connected to 1 and 3. 4 is connected to 1 and 3. Yes. So graph is ready, sir. Now we have to implement BFS for this. So how you can able to implement? Very simple. I'm going to call graph dot BFS of this particular graph. I will pass and then source vertex. 0 is nothing but my source vertex. So okay, let us see. Here I will print system.out.println of, otherwise print of BFS of this algorithm. Sir, now we have to write BFS, right? Sir, what is the code for that? I'm taking static void BFS, which will take a graph G and integer from where we have to start extracting. Now listen my words. I'm going to take the number of vertices. How many vertices are there in the graph? That is nothing but the number of vertices. Boss, I will take a Boolean array called visited. Visited is equal to new Boolean of. How many elements we have to take? How many vertices are there? Those many values. Since the default value for Boolean type is false, automatically all these elements will be filled with false, sir. Now I want to create a linked list which is capable of storing integer just for maintaining the queue. Queue is equal to new linked list I am taking, which will hold integer objects like this. What is the first step? Q dot add of. So source is there, right? We have to add that source into the queue. Now immediately visited of that source will become true, sir. I told right in the diagram, first we have to take a 0, put it in queue and make it as a visitor. That's what I have done. Sir, I inserted into the queue and I make it as visited. Now you have to write a loop until if your queue is empty. If it is empty means it will return false. In such cases, I will run. Okay. If queue is empty, it will return false. Otherwise, I can say queue is empty means it will return false, right? I will take not until not of queue is empty. Until queue is not empty, what we have to do? You need to get a current value, sir. Sir, what is the current value? We have to remove the data from queue. So in this example, we removed from queue, right? That is nothing but the current value. Sir, we have to print this current value on the screen, right? System dot out dot print of. I am printing current value followed by some space. After that, for this current value, which nodes are adjacent? So 1 and then 4. That 2 we have, sorry. 1 second. 0 is the current node. Which are adjacent to 1? That 1 we have to add. Sir, how to find out that? We have already structure is there. Linked list, which is capable of holding these edges. So I am taking some temporary is equal to graph data, adjacency list is there data, get current. Sir, what it is going to do? It will return current node adjacent list. Sir, already you can see in my print screen. Suppose if 0 is there, this is nothing but my list, right? So in that list, edges will be there. Temp is nothing but this list name. In that one edge is there. This is nothing but a temp. In this, 3 edges are there. Like that we have. In this temp, edges will be there. Now you have to check every edge. For each edge value, okay, E present in this temp. Sir, what we have to do? If you have to check, is that visited of E dot destination. E dot destination is equal to false. Means what? Suppose if you take 0 is connected with 1, right? So it is going to return E dot destination means 1. Is visited of 1 is equal to false? Yes. 1 is not visited, right, as of now. Sir, what we have to do in such cases? 2 operations. One is nothing but you have to take visited of E dot destination. Sorry. E dot destination will become true. Then immediately you have to add that destination into the queue. And next edge it will take. Is there any other edge other than this? No. Then it won't be added. Sir, next time 1 will come. Sir, for 1, sir, we have to add, already it is there in the queue. So we have to fetch that and we have to print, and you need to find out the adjacent nodes list. So for this, 1, sir, which nodes will be there? Every node we are going to check. This process will be continued until your queue is empty. Until your queue is empty. But I need to check really, is this code is working properly or not? I have to check. Okay. Now let us compile this code. Perfect. Let us run. Sir, this BFS is nothing but 0, 1, 2, 4, 3. Is it correct? 0, 1, 2, 4, 3. Perfectly we got, sir. This is for graph 1. Sir, if I take graph 2, another graph, like maybe if we take this one, let me check whether we are getting the same result or not. Sir, what I will do is, I will comment this and I will try to write this BFS here. I will write this BFS here. I'm going to put it in a comment. So next I'm going to take another graph like this. Sir, how many vertices are there in this example? 1, 2, 3, 4 vertices are there. Try to take 4 vertices. Sir, connection from 0 to 1 connection is there. Okay. From 0 to 1 connection is there. From 0 to 2 connection is there. Okay, right. Then for 1, 0 is connected. Already it is there. From 1 to 2 connection is there. So next 0 to 2 connection is there. Oh, we have given already. Now we have to talk about 2. Sir, 2 to 1, 2 to 0 connection is there. Already we have given. 2 to 1 edge is there. Already we have given. 2 to 3 we have to take. That's all right. Now if you print the graph, we have to get. And even BFS also we have to get. Let us execute. Sir, 0 is connected with 1 and 2. Is it correct? 0 is connected with 1 and 2. Next, 1 is connected with 0 and 2. 1 is connected with 0 and 2. Correct. Next 2 is connected with 0, 1, 3. 2 is connected with 0, 1, 3. Correct. 3 is connected with only 2. Yes. BFS is nothing but 0, 1, 2, 3. Sir, 0, 1, 2, 3. Like this we got. So I think these two examples, how we got this BFS, it is very clear for you people. Right? If you are clear with this, I will take this big diagram and then I will demonstrate this one also. Can you please confirm up to this clear, friends? Requesting everyone to please respond. Clear? Okay. BFS code not understood. Ayyo. Sir, I explained very clearly. Okay, don't worry. I will give example here itself. See here. Sir, I am going to do dry run. Observe carefully. Suppose consider I have a simple graph is there like 0 connected with 1, connected with 2, connected with 3, and 0 is connected with 2. Like this I have. Now, listen carefully. For 0, which nodes are connected? 1 is connected and then 2 is connected. For 1, which nodes are connected? 0 and then 2. For 2, which nodes are connected? 0 and then 1 and then 3. For 3, which nodes are connected? Only 2. Like this we have. Now, sir, I am calling this graph by passing source as 0. From here, we need to traverse. Sir, how many vertices are there? 4. So it will create a Boolean array with 4 vertices. So 0, 1, 2, 3. By default, all these values are false. By default, all these values are false. Now we have to print the BFS and we have to maintain one queue. Now observe carefully. What is the first step? Q dot add of source. The source which we have given is 0. Add that into the queue. Next, visited of source will become true. 0 will be visited. Is Q is empty? No, it is not empty. Then, so Q dot remove. Remove this from this queue. So which is stored in current. Print this current, which is nothing but 0. Next, linked list temp is equal to, sir, now my temp will become, we will get a list. So G dot add adjacents of get of current. Current value is what? 0. Sir, 0 is connected to 1 and 2. We will get two list objects, two tuple objects like this, 1 and then 2. Okay. Sir, now for each edge, this is one edge, this is another edge. First edge I am taking. Visited of E dot destination. Destination is 1. Okay. Sir, is it false? 1. Yes, it is false. Then E dot destination will become true. 1 is visited and try to add that into the queue. What is the next one we have? 2. Sir, visited 2. Is it false? Yes. Then make it as a true and so add it into the queue. Next, is there any adjacent nodes are there? No. Completed. Then while is my queue is empty? No. Then current node will become q dot remove. Remove 1. Try to print this current node. Now we will get another temp. The nodes which are connected to this 1. Sir, which nodes will be there? 0 and then 2. Now first this one, 0. Sir, visited of 0. Is it equal to false? No, it is true. That means condition not satisfied. It will come out from this. Take next edge 2. Sir, is it 2 is visited? Yes. So no need to assign. No need to add. That's all. Task completed. Now is my queue is empty? No. Then remove the element 2. Try to put it here and try to find out that temporary variable. Sir, temporary list. Which are connected to 2? Sir, we will get 3 elements. 0, 1 and then 3. Take the first one, 0. Is it visited? Yes. So we are not required to do. Take 1. Is it visited? Yes. We are not required to add. Take 3. Sir, is it visited? No. Make it as visited. Try to add this 3 into this queue. Completed. Is there any other nodes? No. Is my queue is empty? No. Then pop the remove the element, try to print, and then again temporary variable will be there. We will get only 2. Sir, is this 2 is already visited, right? So we are not required to add. So completed. Then is my queue is empty? Yes, it is empty. It will come out from this. The output what we are getting is nothing but like this. Can you please confirm everyone? You people got clarity at least now? Please confirm everyone. Okay, right. Sir, the next task what we have here is, for this we have to identify DFS, sir. Okay, DFS means what? Depth first search. Okay, depth first search. Depth first search. Sir, what we have to do in this depth first search? Listen carefully. It is nothing but very simple, sir. We have to keep on moving to the depth. Beyond that, nothing. So we have to keep on moving to the depth. Beyond that, nothing is there. In this DFS, we are going to use some special data structures so that we can get the details in detail. 1 minute, sir. Please wait. One second, please wait. Right. Sir, observe carefully what we are going to do in this DFS. Sir, here also we have to provide the source node. Here, which is the source node? 0. Now, sir, again here also we have to maintain this visited Boolean variable, sir, Boolean array. Because we don't know, right, how many values will be there. There may be a chance of getting loop also. That's why. By default, all these values are nothing but what, sir? False values. Sir, first I will take the node that is vertex called 0. Is it visited? No. Make it as visited and try to print. Right. Sir, what is the adjacent node for this? Which is nothing but 1. Which is nothing but 1. Sir, is this 1 is visited? No. Make it as visited. Okay, make it as a visited and print here. Try to find out adjacent for 1. We have 2 adjacents are there. Sir, 1 comma 2, 1 comma 4. Which you have added first, it will get a chance. Assume I have added 1 comma 2. 1 comma 2. Then immediately it will go to the 2. Sir, is this 2 is added? No. Try to add this 2 and print that. Next, what is the adjacent node for 2? Sir, we have 3. Try to print that 3, make that 3 as visited. What is adjacent node for 3? We have 2 adjacent nodes are there, 4 and then 2. 2 is already visited. Sir, 4. Is it visited? No. Try to make it as visited and put here. What is adjacent nodes for 4? Sir, we have 1 and then 3. 3 is already visited. 1 is also already visited. Any other nodes are there? No, all the nodes got visited. That's all. Like this recursively it is going to call, sir. Like this recursively it is going to call. Let us take another example so that you people will get clarity. For this, I want DFS. For this, I want DFS. Sir, what we have to do? We have to maintain that Boolean array. So 0th location, first location, second location, third location, By default values are nothing but false. Start from 0. Okay, so print that 0, make that 0 as visited. Adjacent node for this 1 and 2, anyone you can select, but which is you have added first will get a chance. Sir, 1. Then what will happen? For 1, is it visited? No, make it as visited and try to put it. Next adjacent node for 3. Sir, 2, is it visited? No, then make it as visited and then try to print. Sir, next take 3, is it visited? No, make it as visited and then try to take. Sir, it is a recursive process, again backtracking will come. For 2, which nodes are adjacent other than this 3? So 1 and then 0. 0 is already visited, 1 is already visited, come back. For 1, we have seen 2 as adjacent, 0 is also adjacent, right? So is it already visited? Yes. Then for 0, 1 is adjacent, take 2, is it already visited? Yes. So backtrack. Any other process is there? No, that's all, it will stop. Okay. Sir, can you please confirm if these two examples theoretical part is clear for you people? I will go with the next example. Can you please confirm everyone, is the concept is clear for you people? Please confirm. Clear, please confirm everyone. Right. So now we will see the third exercise. Here I want to find out DFS. So here also we have to maintain a queue. So to hold, so 0, 1, 2, 3, 4, 5, 6, 7. I am not writing false, sir. We will write directly. First, I will start with 0. Sir, print this DFS, make it as visited. Notes 1, 2, 3 is there. So which is added first? Maybe assume 1. Sir, what will happen? Is 1 is visited? No. Make 1 as a visited and try to print. Then what is adjacent node for 1? Sir, 4. Like this, depth wise it will go. But in the case of BFS, first it will print all its adjacent nodes. Then it will go for next level. Like that it will go. That's why it is called as a level order. But this one is till depth it will. For 1, 4 is the adjacent. Is 4 is visited? No. Then we have to make it as visited and then try to print. For 4, which is adjacent? Only one adjacent is 7. So is it visited? No. Make it as visited and try to print. Then, sir, what are the adjacent nodes for 7? We have 5 already visited. Sorry, not visited. Go to 5. Okay, go to 5. Sir, how it is going to take? Is it visited? No, not yet visited. Sir, we have to take 5 as a visited and then try to make it as 2. Sir, next one will become 2. Okay, next one will become 2. Sir, is 2 is visited? No, it will be visited now. Sir, what is the adjacent node for 2? 0. 0 is already visited. Okay, so come back and come back and then come back. Any other adjacent nodes? 6. Is it visited? No, try to add. Then adjacent node for this is 3, not visited, so take it as 3. So next 0 visited, backtrack, backtrack. Sir, backtrack, completed, backtrack, backtrack. Like this we have backtrack, like this we have. This is nothing but what we have. Sir, this order based on the values which you have added, based on that it will come, sir. Beyond that, nothing. If you have added 0 to 1, 1 to 4, 4 to 7, 7 to 5, like that, then it will become here. Suppose if you have it 0 to 1, 0 to 2, 0 to 3, then 1 to 4, then 2 to 5, like that. If you have added, backtracking will come from here. Okay, because that depends on the values what you have added. Okay, so that's why keep it in mind. It may vary depending on the order which you have added the nodes. Can you please confirm, is this theoretical concept is clear for you people? Right. Now I will implement the program, sir. Program is very simple, right? Because it is a recursion process. I'm going to take same thing here. So DFS. DFS. Okay, we have to pass a graph and then source. Maybe for the last one I am taking BFS is there. Let me take DFS. Okay, I think better after this empty println. Now see what will happen. Sir, we have to implement what things are required here. Listen carefully. So in this DFS, first we have to print that node. Whatever source is there, we have to print system.out.println of can I print 1 second, since it is a recursion, so we have to pass that boolean array also. So new boolean with number of vertices. In the place of source, I will take it as current, and the boolean I have an array is there with name visited. Yes, I will print that current node followed by space. Next and after that, visited of that current vertex will become true. Next, what we have to do, we have to find out the adjacent list for this. So which is nothing but I'm going to take one temporary list here. So where the content is nothing but a graph dot adjacency list dot. So get of current. For this current node which are adjacent, it will come. For each edge E present in this temp, observe carefully. Previously, we have verified whether that particular edge dot destination got visited or not. So if it is not visited, we added to the queue. We added to the queue and we printed. But now here what we have to do, I am calling the recursion. So DFS, I am passing the graph. So which will be the current node? Your destination will become current node, and I am passing that visited array. That's all. Sir, wherever you are coming from here, if you came to here, from this we are going to get here. So backtracking will come after that. Like this, for every edge it will check. Okay, this process will be repeated. When it will be stopped if all the iterations got completed. Now let us run for this and what output we are getting for this DFS. Let us run. Sir, have you observed 0, 1, 2, 3? Is it correct for this? Which graph? 4 vertices. 0, 1, 2, 3. Correct, right? So like this we have. Next and after that, sir, I want to check this DFS even for this graph. Okay, what output we are going to get? Let us cross check. The expected output is 0. Same we are getting, but for BFS it is 4, 3. For DFS it is 1, 2, 3, 4. Let me cross check. 0, 1, 2, 3, 4. Like this we are going to get. So for this big diagram, you try to practice, sir. You will get it the same answers. Okay. Sir, I think the implementation of this BFS and DFS algorithms are very clear for you people. I think so. Can you please confirm everyone, is these concepts are clear for you? I request everyone to please respond. Clear? Right. So based on this BFS and DFS, we have some graph applications are there, like how you can able to check whether cycle is there in the graph or not. I want all paths from source to destination. Okay, is the graph is connected or not? Like we have some applications are there. Tomorrow we will talk about that applications. Okay, tomorrow some graph applications I will take. Even day after tomorrow also we are going to cover some graph applications. Okay, yeah, cycle graph. Yes. Swapnil, minimum cost spanning tree is there. There you will get clarity which one is best. Okay, right. So thank you guys, see you tomorrow.